We're on part 5 of the fractions packet, graphing rational functions. We have the form f of x equals a over x minus h plus k. So let's look at the first one. This is the parent function, 1 over x. So that graph, if you were to graph that in the calculator, it will have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. And your graph will be in the first and third quadrants. So your h is 0 because there's nothing here in the denominator except for x. So that means your vertical asymptote is x equals 0. Your k, there's no k here, so it's just 0. Your horizontal asymptote then is y equals 0. Domain is going to be from negative infinity to 0 and 0 to positive infinity. Pretty much everything except for x can't equal 0. Your range, same thing. And for transformations, since this is the parent function, there's no transformations. Let's look at another one. Let's look at number 3. So our h is 1. So that means our vertical asymptote is at x equals 1. K is negative 2. So y equals negative 2. Notice there's a negative sign out here. So instead of the first and third quadrants, the graphs will be in the second and fourth quadrants. So let's draw our asymptotes first. And then we draw our graph. For the domain, it's going to be from negative infinity to 1 and 1 to infinity. And our range is negative infinity to negative 2 and negative 2 to infinity. Our transformations, since there's a negative here, it reflected across the x-axis. There's a minus 1 here, so it went to the right one. And then there's a minus 2, so it went down. So reflect across x-axis, right 1 and down 2. Try the rest of the ones on this page yourself. If you go to the next page, we have 1 over x squared. It'll be similar, except The parent function will be in the first and second quadrants. Same asymptotes, though, as the first parent function from the other page. Okay, let's turn to the next page, partial fractions. So we have 4 different cases. Let's do the examples for each of them. So we have case number 1, distinct linear factors. So since we have distinct linear factors for both of these, we're going to find a over x plus 4 plus b over x minus 7. So we'll set these equal to each other like this. And then we're going to get rid of the denominators. So to do that, we're going to multiply everything by x plus 4 and x minus 7. So these will cancel, these will all cancel, and those will cancel. So what we have left is x equals a parentheses x minus 7 plus b parentheses x plus 4. Distribute, multiply each term to get this. Now we want to get all the x's together and all the constants together. So really we have x plus 0. Our constant sum should be 0, and our x sum should be x. So we'll go ahead and write those out as a system of 2 equations. So if x equals ax plus bx, and 0 equals negative 7a plus 4b. So in this case, we know that all of them are going to have x's, so we can just get rid of those x's for now. So we have 1 equals a plus b. If we solve for one of the variables, we could have a equals 1 minus b. Let's plug that in to this equation to get our solution. Distribute the negative 7. We have negative 7 plus 7b plus 4b. Add the 7 over to the other side. We have 7 equals 11b. Divide both sides by 11, so b equals 7 over 11. And since a equals 1 minus b, 1 minus 7 elevenths would be 4 elevenths. So a would equal 4 elevenths, and b equals 7 elevenths. So if you put those together as your decomposed fraction, it would look like this. Okay, now let's look at example 2. We have 8 over x squared plus 3 times x squared plus 9. That's going to be case 2, distinct irreducible quadratic factors. So from here, we're going to set them each equal to each other, and then we're going to multiply everything by the denominator. And from here, these will cancel out, and these will cancel out. So what you have left is 8 equals a plus bx times x squared plus 9 plus c plus dx parentheses x squared plus 3. So using box or FOIL, you'll go ahead and multiply each of these out. And so once you get that, we're going to turn this into 4 separate equations for a system of 4 equations. So our constants, so we can really think of it as 0x to the third plus 0x to the second plus 0x plus 8. So we'll do our constants first. 8 equals 9a plus 3c. And we'll go ahead and move on to the second one, our x's. So we have 0 equals 9bx or just 9b actually. 9b plus 3d. And then we'll move on to the x squareds. So 0x squared would equal a plus c. And then for the x cubes, we have 0 equals b plus d. And then if we go to our calculator, we go to calculate menu 2 to get lid solve. We have the box pop up. Instead of pressing enter, go ahead and change that 2 to 4 because there's 4 different equations here. And instead of x and y, type in A, B, C, and D. And then press enter. Type the first equation in the first box, second equation in the second box, and so on. Once you press enter, you should get the solution 4/3, comma 0, comma negative 4/3, comma 0. So this was A, B, C, and D. Now B and D would have always been 0 because notice 8 does not have an X. So B and D will either be 0 or they would have canceled out here. So using that, we'll write in our final answer. And this is your decomposed form. This is your partial fractions. Okay, let's look at example 3. So we have 2x plus 2 all over x plus 5 squared. So we have case number 3, so we're going to set it equal to this. So we're going to multiply each side by x plus 5 to the second power. So these are going to cancel out, and one of these are going to cancel. So what we have left is 2x plus 2 equals a parentheses x plus 5 plus b. So once we get here, distribute the a, multiply each term. You have 2x plus 2 equals ax plus 5a plus b. From here, we can set up our system. We have 2x equals ax. And then we have 2 equals 5a plus b. So to solve for a, it's going to be something times x equals 2x. That's just going to be 2. A equals 2. Plug that in to solve for b. 5 times 2 is 10. 10 plus some number equals 2. Subtract 10. So b equals negative 8. So we just plug those back in to our form right here. We have 2 over x plus 5 plus negative 8 over x plus 5 squared. And that is our decomposed partial fraction. Now let's look at the last example here, example 4. We have x squared minus 2 all over x squared plus 6 to the second power. So that's going to be case number 4, repeated quadratic factors. So we'll set it equal to our partial fraction right here. From here, we want to multiply each term by x squared plus 6 to the second power. So those would cancel, and one of these would cancel, and both of those would cancel. So what we have left, and what we can think of, is 0x cubed plus 1x squared plus 0x minus 2 equals a plus bx times x squared plus 6 plus c plus dx. So from here you can use the box or FOIL method to multiply each of these out. So from here we can set up our system of 4 equations. Let's do our cubes first. So x cubed. So we have 0 equals b. And we're done with that one. Okay, let's do our x squared. So 1 equals a and that's it. And then we have 0 equals 6b plus d. And then we have negative 2 equals 6a plus c. So after we have our system of 4 equations, we could go to our calculator. Go to Calculate, Menu 3-2. You'll type in 4 equations in the box instead of 2, and press A, B, C, and D for your variables, and press Enter. Enter the first box, second the second box, and so on. Once you press Enter, you should get this right here. You get 1 for A, 0 for B, -8 for C, and 0 for D. Now, this particular problem right here would have been easy to do substitution with since you already had 2 of the variables identified. B was 0, so 0 plus D equals 0. D must also be 0. Same thing with this one. 6 plus something equals -2. -2 plus -6 is -8. So if you plug these in to our partial fractions, you should get 1 over x squared plus 6 plus, or you could just put minus, 8 over x squared plus 6 squared. And that would be your decomposed partial fractions answer. Okay, now you try this one on your own. Which case is this? Which one does that look like the most? And then find the partial fraction. If you need another piece of paper to use for this one, go ahead and do that and attach it to your packet. Let's turn the page to our word problems. Suppose Ralph can paint an entire house in 12 hours, and Stephanie takes 8 hours to paint a similarly sized house. How long would it take the 2 painters together to paint another house that's the same size? Well, Ralph could paint the house in about 12 hours, so that'd be 1/12 of some time. And Stephanie takes 8 hours to paint a house that's about the same size, so 1/8 of some hour. How long would it take the 2 painters together to paint another house that's the same size? It's only talking about 1 extra house, so we're going to set this equal to 1 and solve for t. Now we want to get rid of these fractions, so to do that, we can multiply everything by the least common multiple. If you're not sure what that is, you can press calculate, menu, 2, and then 4. Put 12, 8, and then enter. You should have 24. So to get 24, you will multiply 12's fraction by 2, and 8's fraction by 3. So we have 2t plus 3t all over 24 equals 1. 3t plus 2t is 5t. So 5t over 24 equals 1. So let's cross multiply. So we have 5t equals 24. Divide both sides by 5. You get 1t equals 4 remainder 4, which is the same thing as 0.8. So t equals 4.8 hours. Number 2, to make 20 biscuits, Juanita uses 2 cups of flour to 3/4 cups of milk. If she uses 3 cups of milk, how many cups of flour will she use? Well, so the 20 biscuits is something extra in this case. So we have 2 cups for every 3/4, which is the same thing as 0.75, and 3 cups for how many flour. So flour over milk equals flour over milk. So now we'll cross multiply and solve for F. We have 6 equals 3/4 flour. To get rid of the fraction, we flip and multiply. 4/3, 4/3. 6 divided by 3 is 2. 2 times 4 is 8. So F equals 8. 8 cups of flour. So go ahead and try the rest of these in your groups or on your own. Turn in this packet today, even if you don't finish it.